Hello, I'm Julia Perkins. So, before we did these experiments, we actually did a little tester, and we put a penny in the same amount of around the same amount of hydrochloric acid. But before that, my dad sanded it off and put it in. Pennies are made of 100% zinc, but they are electrocoated with copper. It may look like it's a normal penny, but it's not. Now I'm going to reach in and, I'm going to try to reach in and flip it over. Just saying my dad washed it so it doesn't really have any more hydrochloric acid on it. So I'm just going to pick this. Whoa. There's just like a plate. Yeah,
Keep it down there so we can see it.
It is a plate. It's just like, look at that. Look at that. This is the other.
Now, can you flip it back over again?
Whoop.
There you go.
Normal penny. Unnormal penny.
Okay.
Normal penny. It actually feels like, this actually feels.
What happens if you squeeze it? Oh my gosh, look at that.
It actually feels like it's, you know, that wrapper that's like for those golden coins, it actually kind of feels like that. So as you can see, penny.
So what does that tell us about what reacts with hydrochloric acid? Did the zinc react?
Oh yeah, it turns out like only the zinc reacted because the copper. This is actually a hint on like our later experiment with copper. So this is a foreshadow. So it turns out that like the copper, I don't think reacted at all because, as we said, it's a thin, and this is about as a electrocoated, I'm guessing, would be.
Mm-hmm. And the zinc, where'd the zinc go?
The zinc, I don't think we'd live to see any more days. Its lifespan was 12 years. We're getting ready to do experiment 1 on putting a 0.3 ounce stainless steel screw into 31% into 100 milliliter or 31% hydrochloric acid. And our starting time is 1:26. We are getting ready to do experiment 2 with brass, which is made of 70% copper, 30% zinc, again in 31% hydrochloric acid. Our starting time is 1:33. We are starting our experiment 3 with our 0.3 ounces of aluminum in our 31% hydrochloric acid. Our starting time is 1:40. That is what it looks like about 5 seconds after we poured it in. So many bubbles. I think that one might be the one that is almost fastest. That is way faster than the stainless steel. I'm not going to be surprised if it's all gone.
This way, boy, it won't make it 3 hours.
Yeah. So we might have to check on that every 30 minutes or so, just to make sure that's not all gone before we finish this test.
Yeah, we'll see if we can keep track of it.
Yeah.
And we'll take a note, like when we see it has disappeared.
Everyone.
Which I think is only going to be like another minute or 2.
So everyone at home, don't be surprised if it's all gone by the time we finish this test, because this is, I guess, very, I'll just say easy to dissolve.
It's aggressive.
The time is now 1:46, and this is what happens, and don't be surprised if it's all gone by the time we're finished. Once again, we're looking at the aluminum because we have to watch it or else it will it will be gone.
Oh
by
boy,
the
look at
time
that.
we
It's
check on
doing
it.
something.
Whoa, that looks like it's boiling, just saying.
What time is
That's-
it? What
it's
time is it
kinda-
now, Julie?
Wait, watch this. It's 2:40.
No,
No,
150.
that'll be.
Oh boy, look. Get back, everybody.
Never mind.
Look at that. Oh, it's coming over the side. We'll bring in our emergency hydrochloric acid. Or
I
our
accidentally broke it open and it's not very pleasant. Yeah, put baking soda in there. Then it's about here.
come out of the house, everybody. Yep, just have a little, lots of vapors.
Did we get in the front door?
Yeah.
It's actually warm outside.
Wow. Yep.
We're gonna have to wait a little bit until we can get our started.
Well, it just took off at one point. What's the time, Julia?
I don't have my watch with me because I had to evacuate. It's probably between 150 and 155.
Okay. I see 151.
Hello. Well, this is what the aluminum, I'll just say Mark 1 looks like. We're going to have to do another one because it's kind of like exploded in fumes, and as you can see, it actually took out one of these strands of aluminum, as you can see right there, and so we are going to have to do Mark 2 later on, and it looks like we lost a lot of the acid. Now, well, during our aluminum experiment, about shortly after we put it in, about like 10 to 20 minutes after, acid started bubbling out and it kind of erupted. Shortly after that, we had to go outside because it was very hot. Well, I kind of went outside here because that was my only way of getting fresh air because it was stinky in here. It was actually hard to breathe too. So now it's all right. We opened the doors for like 5 minutes and it kind of started to go away. And as you can see, we had to put a bunch of baking soda. And it is experiment number 4 with our 0.3 ounce of solder, which is made of 40%, 60% tin, 40% lead. I think I was wrong about this. It's getting off at a good start, but the aluminum, it's only 1 hour. It's only 1 hour, and I'm guessing it's all gone.
Okay.
This is test 5 with 2 carbon steel nails, which we are going to count as 1 0.3 ounce carbon steel nail with a zinc coating. Carbon steel is apparently 99.6% iron, and it is 0.4% carbon. So I don't know why they exactly called it carbon steel if it's only 0.4. I guess they were very specific saying that it is some carbon. So our starting time is, let me make sure. Okay, I'll just say 2:38 since it's currently 2:37, so 2:38.
Okay, you ready? Can you put those in my hand, the nails?
Oh, here.
All right. Okay. You ready to put them in?
Still smelly.
Yep. Here we go.
Whoa.
Oh boy. Nice reaction. Oh, that's the zinc.
Put a bunch of baking soda.
We're ready on standby with the baking soda if needed. So we know, what do we know about zinc from the penny experiment?
Basically that is very, I would say, well,
It dissolves.
yeah, it's very weak against hydrochloric acid. It's probably like a little tiny.
So now look at the bubbles. What do you see happening now?
They're getting a little bit slower.
Why do you think it's slowing down? What might
Because the zinc is running out, because it's only probably like an electroplate coating of zinc, but so later on I might get to see on according to stainless steel. I'm not sure that would be as fast, but I wonder if the acid will turn green again.
It's a good question. Because we're looking at the stainless steel and what's happened over at the stainless steel.
It turned into Mountain Dew.
All right. Yeah, then the screw's still very much there, but it's bubbling
You
a
know
little
what?
bit.
You know what screws still very much there? Its neighbor.
The brass looks completely unaffected.
Brass is putting up real fights.
Now, meanwhile, what's happening to the solder alloy?
The solder alloy. Oh, I haven't really been looking at that. I hope it doesn't turn out like the aluminum. I don't want to evacuate again.
And look over at the nails again now. See what's happening with the nails.
Ooh, you can definitely see them bubbles.
So I wonder if we're past the zinc and down to the carbon steel now.
Yeah, but the carbon steel is actually working.
If that's true, yeah.
Wow.
We can only guess.
Yeah. I guess the iron and the stainless steel are not the same.
So what's the difference between the carbon steel and the stainless steel? But what is in the stainless steel alloy that's not in the carbon steel?
Chromium.
All right. How much chromium?
18%.
Interesting. So I wonder if that's what makes
Yeah.
the difference
Oh,
here.
maybe. Well, maybe the chromium is a little bit stronger. Also, maybe the chromium was what caused the acid to go green.
Yeah. Good questions.
And on this video, it might look like the
And meanwhile,
chromium.
what happened back over in the aluminum? The aluminum looks like it stopped.
Yeah, the aluminum looked like it went bye-bye.
It stopped, but there's
We're gonna have to
certain-
do a Mark II, so if you want to see a little bit more, you can still see the Mark II later on.
Okay, we'll have to go back and regroup on that one, huh?
Yeah.
Figure out a new way to do that test. Okay, go.
So this is our 6th experiment with our 0.3 ounce copper and our 31% hydrochloric acid. Our start time is 2:46, and this is electro-refined copper, made for electrical use because this is not an alloy at all. So our start time is 2:46.
It's not an alloy?
No.
Okay, so that means it's 100%?
Yes.
Tell me.
Says it right here.
Okay.
Says it right here.
Yeah, I want you to say it.
It is 100% and electro-refined copper.
Okay.
No alloy.
What do you think's going to happen when we put it in the acid?
Well, I don't think it will get very... It might have small bubbles, unlike the brass. Hey, Dad, you know what I'm surprised about the brass?
Okay, hang on.
Sorry. So
But what did you observe about the penny?
the penny was made of copper and zinc, and it turns out the zinc wore away, unlike the copper. But I'm surprised about the brass. As it says here, it's 30% zinc and 70% copper. Maybe it's not bubbling too much because of the copper, but what about the zinc? Is the zinc deep inside so the acid cannot get there? But if it was on the outside, I'm pretty sure it would be bubbling like that. Not that, because that was crazy, but maybe like this and this.
So I can tell you that the brass alloy is all mixed together. So
Yeah,
what's
but
on
I'm
the out?
wondering about why it's not getting this.
Mhm.
Like why it's not acting as if it was only zinc.
Right.
It's
So I can tell you
only-
there's no copper coating on that. That's
Yeah.
just brass through and through.
Yeah, but I'm not. But that's weird. I would actually think, now that I've had experience with zinc and this, I would think that the brass and the zinc would actually help tear away the brass, but the copper. Like I thought the copper would bubble a little bit, since on that the copper was there. Maybe it has something to do with it being mixed together, and the zinc being combined with the copper.
Maybe so.
Maybe that makes it stronger than copper and zinc.
So we're getting ready to do experiment number 6. What's that?
Electro refined copper. We don't really see any effects happening right now, so copper probably won't be the strongest one.
Well, you mean copper is resistant to corrosion.
Yeah.
So it's very strong actually against acid, hydrochloric
Yeah.
acid. And what
And
was very weak against hydrochloric acid?
Zinc
Zinc.
and
Interesting.
aluminum. We are going to dip this pH test paper into hydrochloric acid and see which level of acid it is. So if you're thinking, oh, it's going to be a 14, of course. No, it isn't, because 14 is actually the base side. So I'm expecting like one or two or 0. It doesn't really show 0 on this, but it might be around this final
Okay,
strip.
ready? I'm getting ready to dip it. Here we go.
Yeah. So okay,
Okay.
put that over there. That's actually like a velvet, so I'm guessing that would be around 0.
I don't know that it goes to 0, but we'll find out.
It goes to 1.
The lowest
yeah.
it goes to is 1?
Oh yeah.
Okay.
Yeah, that's definitely a 1.
All right. So it's reading a 1 on our scale. It's 3 hours later. What do we know about the first experiment?
Well, our first experiment was stainless steel. As you can see, it is still bubbling at the moment, and it is a kind of Mountain Dew color. Experiment number 2, experiment number 2 didn't really do anything. Experiment number 4 is very weird. As you can see, we used that curled up solder, which is spelled SOLDER. And as you can see, there's like these black strands on the top. But when you look down into the glass, you can see that black layer. I don't really know how that happened or what the black things are. All I know is that experiment number 4 was very strange. Not what I was expecting.
All right.
Well, experiment number 3 was also very strange. When we poured the aluminum in, it all started just going immediately, and in about 5 to 10 minutes, it just rose up and splashed out.
Okay, so this is the solder that we put in the acid.
That is
Okay, what do we see here, Julia?
the solder. So just saying, my dad kind of rinsed all the acid out and filled the cup with water.
Yeah, I was in the process of doing that,
And
actually. And then I noticed that these little wires that were left over on the inside were floating 2/3 of the way up in the glass. So on the bottom is a black layer that we don't understand, and then up at the top is the top of the water. But the solder is, or these wires, are floating about 1/3 of the way up. Now watch what happens if I rock this back and forth. Do you see that?
Yeah.
It's like there's two different kinds of liquid in the glass right now. Maybe the acid is still on the bottom and the water on the top.
I honestly do not know.
I do not either. So those little black wires are floating right at the boundary between the liquid on the bottom and the liquid on the top. Isn't that weird? Do you see the wave in the middle of it? It's like there's two liquids in there. You think so?
Yeah, there's the hydrochloric acid in the
Well,
water.
I don't know what it is that's on the bottom. I'm not sure. See, the thing is it might have changed into something else. It might have changed from hydrochloric acid to something different, you know, chemistry.
So
But what-
you can see that wave, like, it just seems like that it's resting on. Oh, I have an idea.
What's that, baby?
So maybe the hydrochloric acid floated to the, well, went to the bottom, and the water was up there. But maybe the solder would sink in water, but for some reason it would float in the hydrochloric acid. So whenever you tilt it like that, the waves of hydrochloric acid are changing. So that also moves the thing. Well, the wire is the same way.
Maybe. That's a good theory. Okay, I'm recording. Tell me what you're going to do.
We are going to see if this will, if stirring it a little bit will change the way that the solder moves, and see if the acid and the water will actually mix.
Okay.
Looks like bubble soap.
Okay, now take it out and see what happens.
Set it on that cloth.
Yeah. No, just on the table. Just rest it right there. Well, it looks like everything's coming back to that same level
Well,
again.
there's only one thing that's actually circling above. At that top.
Okay, now let's rock it again and see if that layer is still there. You ready? Look,
Yeah.
it's still there. So,
I'm
sweetheart,
guessing. Oh, I have an idea. Maybe it was stirring, but then right after that, the water went to the top and the thing went to the bottom. So stirring was just a temporary.
why don't we do another experiment? Why don't we fill a glass halfway full of acid
Why
and
don't
then
we?
add some water on
Yeah.
top of it and stir that and see if we get that same level.
Okay. All right.
Yeah. But I'm not convinced that that is hydrochloric acid on the bottom, because if it was hydrochloric acid on the bottom, wouldn't it still be dissolving the solder? Or maybe it has already finished dissolving the solder and what's left there is something else. I don't know.
Well, maybe. If we look at its formula, then it says it is 60% tin, 40% lead. So maybe it just dissolved one of the things, and the other thing is very hard to dissolve, like the copper or the brass.
No, so you're thinking maybe it dissolved the tin and left the lead behind?
Or it
dissolved the
dissolved
lead and
lead
left
in
the
the-
tin behind?
Yeah, because just like that penny, it dissolved the zinc and left the copper behind.
So what would be neat if we did another experiment would be to see how pure tin and pure lead reacts with the acid.
Mm-hmm.
Okay, that'd be future time. Interesting. Okay, it's been 3 hours. What can you tell us about experiment number 5?
Well, experiment number 5 is carbon steel with the zinc coating. I can tell that it's still reacting because of those bubbles, as you can see down in the transparent side. It's also transparent at the bottom and it's opaque at the top. Well, experiment number 6 was the one with the electro-refined copper. All that I can see is the same thing that it was in the very beginning. I don't think it is reacting at all now. All you can see is the little tiny bubbles that were formed in the beginning.
Okay, this is a glass that has acid in it. Now what I'm going to do is pour water into the top slowly and see if we can get those 2 layers to form, like what we saw in experiment number 4. Okay. Okay, here comes the water. And now I'm going to stir it a little bit, just like we did. I don't see any layers right now.
Can I mix it?
Yeah.
All right.
Okay.
Let's see.
Now let's slowly stir it. I see some different densities in there. See those swirls?
It kind of looks like bubble soup.
Those are swirls that you see when you see the different densities mixing. Okay, now that looks like it's really actually mixed together now. I don't see 2 layers. Okay, here's our experiment number 4 glass. We'll put in our plastic stirring rod. Give it a good stir.
Let's see.
It's a pretty vigorous stir, isn't it?
Yeah. Okay,
Okay.
now try taking it out.
All right.
Let's see if all of this flips actually out from the same place.
It all has a different distribution now.
Yeah.
Maybe it is starting to mix up.
That's neat.
Yeah, you want to stir? Let's try it. This is a melamine thermoset plastic that we're using to stir.
Okay, Dad.
Okay, let's see what we see.
Sorry. You can see the tiny black particles.
They're dancing around there, aren't they? Like they're just about neutrally
I
buoyant.
think we mixed it up because now it all floated to the bottom.
It is. It definitely did. It had some effect on it. Well, I think to me it's a mystery.
Strange.
That really is, isn't it?